In this video, we can solve a problem related to the medium industrial electrical design. So the problem is draw the single line diagram of a transformer substation of 400 kVA 11 kV bar 415 volt dry type transformer. Specify the rating of each unit at the primary and secondary side of the transformer with the proper justification. So that is the question. So in question, the capacity of the transformer is given. So that is 400 kVA. Then voltage rating of primary and secondary is given. 11 kV for primary, 415 volt in secondary. And also we use a dry type transformer. So normally dry type transformers are used in indoor type substation. Okay, dry type transformers are used in indoor type substation. So we can select indoor type substation and we can draw the layout of indoor substation. Now we can draw the layout of indoor substation. So this is the layout of indoor substation. So in this layout, so the supply is coming from the service provider, that is 11 kV. So it connects to a GO. GO means gang operating switch, or AB, air brake switch. So this switch is used for break or make the circuit. Okay, and the voltage rating of this switch is 11 kV. That's why we are writing the voltage rating is 11 kV. And we use a 11 kV lightning arrestor. So that is a part of indoor substation. Then we use a 3-core underground cable. 3-core underground cable that connects to our transformer. So 3-core, 11 kV 3-core underground cable. Then for metering purpose, we connect CT and PT. So this is the PT and this is CT. And these two current and voltage measurement is connected to metering, energy meter. And then we connect a circuit breaker, 11 kV circuit breaker. Then we connect a transformer of 400 kVA, 11 kV bar 415 volt transformer. Then secondary of the transformer is connected to the LT circuit breaker or low tension circuit breaker. Then we connect a bus bar. From the bus bar, we connect different individual switches. So that is the layout of indoor substation. Now we can define the circuit breaker, primary circuit breaker and secondary circuit breaker. Then we can select the proper sizing of primary cable and secondary cable. So primary cable actually 3-core underground cable. Then secondary cable is 3.5 or 3.5 core LT cable, because the transformer connection is delta star connection. So primary side only 3 wire is there, but in secondary side there are 4 wire, 3 for phase wire and 1 for neutral wire, and the size of the neutral wire is less than or half of the size of the phase wire. That's why we are writing 3.5 or 3.5 core LT cable. Now we find out the primary and rated current of the primary and secondary rated current of the transformer. So what is the equation to find out the primary and secondary current of the transformer? So first we calculate the primary side. Okay, so we are moving to the primary side calculation. So initially the primary current. Okay, so primary current. So the primary current is equal to, that is IP, primary current, that is HT side, primary current equal to kVA into 1000 divided by root 3. It is a 3 phase, so root 3 into voltage. So kV into 10 raised to 3. Okay, so IP, primary current, equal to, what is the capacity kVA rating? That is 400. Capacity of given transformer is 400. So 400 into, we convert into VA. So into 1000, 10 raised to 3, divided by, in numerator, root 3, because it is a 3 phase, into what is the voltage? 11 kV. So convert into voltage, 11 kV to voltage. So 11 into 10 raised to 3. So we get 20.99 ampere. Okay, so that's why that is the primary current of given system. So we should install the circuit breaker of primary side above 21 ampere or 20.99 ampere. Okay, so you can choose 25 or 30 ampere circuit breaker in primary side. 25 or 30 ampere for circuit breaker for primary current. So we can write the current rating. Okay, current rating of this circuit breaker, that is 25 or 30. So the exact sizing of the circuit breaker is 11 kV, 25 or 30 ampere circuit breaker, because that is based on the rated primary current of the transformer. Okay, then we can select the cable size. So cable size also we choose based on the primary current of the transformer. Okay, so the primary current of the transformer is calculated, so that is 20.99. So from the data book we can choose the rating of, okay, current rating, sorry, cable size required in the primary side of the transformer. Okay, so you can write that value. And also HT fuse rating. Okay, you can use 40 to 63. Fuse rating should be 40 to 63 ampere. So that's all HT connection. Okay, then one more thing. Suppose the up to kVA, 400 kVA, we can use VCB. So our given rating is 400 kVA, so we can use 11 kV 40 ampere VCB. Okay, 11 kV 40 ampere, 40 or 30, okay, 40 or 30 ampere VCB. Okay, now coming to the secondary side of the transformer. In secondary side, first we calculate the current. Okay, so the same equation, secondary current equal to kVA into 1000 divided by root 3 into VL. Here kVA equal to 400 into 1000 divided by root 3. What is the voltage? That is in voltage, VL. Okay, so into 415, you get 556 ampere. So that is the secondary current of 556, secondary current of the transformer. So we should install the fuse rating of secondary side above 556. So from the data book, we can see that 600 ampere LT circuit breaker is used. Okay, so the current rating of all the devices in the secondary side should be 600 ampere. Okay, and size of the cable 3.5. So actually 3.5 is the size of the cable. So from the data book we can see the size of cable required in secondary side corresponding 400 kVA is around 300, okay, 300 mm LT AY-FI cable. So this data we get from the data book. Okay, for 400 kVA transformer in secondary side we use 300 mm LT AY-FI cable. Okay, so we can write here the cable size is equal to 3.5 300 mm core LT cable, and size of the LT should be 600 ampere. Then size of the HT circuit breaker is above 25 or 30 or 40 ampere. Okay, so that is the solution of this problem.